Okay, hey everyone, thanks for joining. My name is Michael Molina. I'm with the Oklahoma Transportation Library and Southern Plains Transportation Center. And thanks for joining us for our webinar series. Today we have Eric Dixon, the Senior Product Manager at Harris Corporation, and he's going to be talking to us a little bit about some of the technology developments going on. And pardon me if I hope I get the title right. It is Helios, How Repurposing Existing Infrastructure Sensors in the Age of the Internet of Things and Machine Learning is Improving the Way Transportation and Business Combats Weather Interruptions. So it's a mouthful of a title, but it looks fascinating, and with graphics and images, I mean, it looks like there's a lot of cool stuff here. So thanks everybody for joining, and without any further delay, I'll go ahead and turn it over to Eric.
Hi everyone, thank you again for joining. I want to go over some pretty cool technology that I think everyone will enjoy. So I'll be doing a real-time demonstration because I think we have weather going on in the United States. And I'll switch between a real-time visualization system that the Harris Corporation has put together and some background slides just so you can get some indication of why we're doing what we're doing. But I want to start sort of with the slide presentation just to give you a background of sort of the beginning stages. And for those of you who are online who are technologists, you'll kind of get, sort of why we started this. So why Helios? For me, why the weather? Because of fear. In 2012, there was a major derecho that came through the Maryland suburbs where I live. And I was in my sunroom, and I could see that the weather situation was really getting bad. And I turned on everything that I could find, from radio to television to the internet, and I could not see what I was seeing out of my window. And I was fearful for my family. And that started to make me think, because there was, even though it was a very dangerous situation, there was really no actionable information that I could find on localized weather. And I'm a technologist at heart, and we're always looking for new methods of how to improve these types of problems. And my epiphany really was around, could I apply some new technology in ways to perform tasks where they previously weren't? So could I look at big data and big data analytics and that promise and kind of look into that technology and tackle this problem that I was having with localized weather, or at least with the situation that I had experienced with my family, where I didn't have the information to know what actually to do. And, we want to solve, big problems and improve everybody's ability to kind of respond to those, right? So that was the genesis of what I'll show you on Helios. Now, what I found out as I started to explore this more is weather, excuse me, and I don't want to bring politics into this, but weather is like politics. It's very localized, and I didn't realize that initially back in the day when I was first doing that, but weather is very, very local. Helios is part of the National Weather Service Measurement Program, and when the forecasters were looking and evaluating Helios, they actually told us that even they, before they put out a forecast, look out the window or look out the door before they put down a nowcast, which is interesting, because I bet you everybody on this webinar, this morning when you got up, you looked out your window. And why? Why do you do that? You ever asked yourself why? Because that's the best way for you to get ground truth on what's happening where you are at the time that you want. So we started to realize that, forecasting is very good, getting better, but what happens in the atmosphere is not always what happens on the ground. And of course, expected zones, they're not really what the actual really turns out to be. And that can be very important in transportation and mobility and transportation safety. All of that is kind of critical of knowing exactly what happens. So storms have pockets, right? Intensity is different, and we see that with the derecho that I experienced, that some of these things are very localized in nature. And many times, ground weather sensors or orbit stations or even airport ASOS stations may be sparse and limited in many areas. So this is a case that, you know, kind of furthered us into our development of Helios, and I wanted to give you a little bit of a background. And the other overall premise was we saw all these cameras, right? And we're like, well, there's cameras all over the place. And you ask yourself, when you look into a CCTV camera, even at the state DOT level, what do you see? Traffic. That's only because that's what that camera was put there to see. So is a camera just a traffic camera, or is it an underutilized sensing asset? So what do you see? Most people see traffic. But this is what we want Helios to start to see. So what we envision is that we can transform that camera, even with low resolution, high compression, into this observation sensor, and we can actually retrofit cameras to look at other things, right, other phenomenologies, and kind of build this big data, Internet of Things, and start to look at environmental, which I'll show you with Helios, tracking, activities, patterns, and usage profiles. So that's sort of a big picture look at the technology, and if we have those from universities and other institutions that are doing research, I wanted to give this broader picture of Helios because right now we're going to show you weather, but this platform can be extended out into other types of phenomenologies that might be of interest to you that we could possibly work together. All right, so Helios really is this cloud-based weather, we call it a weather observer. It can take, if you look at the upper left, it can take all these cameras, millions and millions of cameras into this Amazon framework, and we have these componentized weather analytics that perform machine learning against the camera systems. And from those camera systems, we get if you look at the right side and the right top, there's cameras, but those cameras are actually transformed into weather sensors. No retrofitting of the camera, but it's all done through machine learning. And let me give you a sense of sort of what that looks like. If I take you into the actual application, and this is a visualization of our network. So the gray dots are really the cameras, and as you zoom in, you can see that the cameras fill, and fill, and give you an indication of each camera. So each camera that we grab is bringing in, let's see if I can grab one that's, we're on WebEx. Okay, there we go. So each camera is either giving us a single frame imagery at about 5 to 10 minutes, or it's full motion video. We're grabbing all of that imagery from every camera that we have across the United States, Alaska, Sweden, Germany, Finland. All of that is being pushed into this framework, right, that allows us to do these big data analytics. And then from that camera imagery, I can very simply flip, and I'm going to flip on our visibility analytic. And I can turn those cameras into more, to display more of weather, or what's happening in the weather or environmental space. And what I basically did is I flipped the visualization. So now I'm showing you the grays are where visibility is good, the reds are where visibility is altered. So if I click on one that's maybe altered, you can see that there's things happening. Visibility has now, the visibility icon that's here is more of a somewhat hazy. So we go from infidelity from good to hazy to reduced to really poor. So we have all those fidelity ranges within the machine learning analytics, and we can do that with visibility. So those cameras actually become, instead of cameras, they become weather sensors. And we do that. Let's see if I can zoom out really, really far so I can give you an indication. So we cover the whole United States, including down into Florida, Louisiana, Texas, even the southern states, and up into Alaska. We cover Alaska, parts of Canada. We're starting to do that. And then if we come over into we have the United Kingdom, Sweden's coming along, Germany will be in really soon, and Finland. So we're doing all of this on this big platform that exists called Helios, right? So it's sort of Amazon, very componentized platform. So let me go back a little bit, just give you a little more background. All right, so we have this is happening, and we collect this imagery every 5 minutes. So anyone on this webinar, if you have cameras or you have assets that maybe are not part of Helios, we can work together to work on projects to where we can very easily ingest any of your camera assets and work these analytics. If you have research in the machine learning area, we have a framework that's up in the upper left that will allow you to, if you want to create machine learning analytics that work against all of these camera assets, and you want to maybe create a tracking algorithm, we also have the ability to work with you to pop an analytic into that framework, and you can actually run that analytic in real time across our network, right, in a research sort of environment. All of that is capable. So how a CCT camera becomes a weather sensor, we have this ubiquitous, persistent networks, always looking. And by the way, the cameras do move. They pan sometimes from, you know, dawn to dusk, just so, and they also move because of traffic. So we have image science pre-screening and QA capabilities to where that doesn't hinder our accuracy in our development of our analytics. So we have this ubiquitous camera network. We have this big data as a service platform with these weather analytics sitting in them. And then we pump that through those analytics, and we come out with this ground weather kind of conditions. So we're actually sort of retrofitting. We're automatically sourcing and data collecting into this ubiquitous cloud, right? We do the machine learning. We maintain a persistent look, and then we're able to train the machine learning to actually look at the phenomenology that we want, and we get great results. We're able to look at these cameras across seasons. We're able to look at them across years. We're able to look at cameras individually across seasons, years, and we're able to model to that. So, you know, like I said, if you're doing research in the machine learning side of things and you're looking at traffic, congestion, all of those kind of things, this framework is capable of actually helping you and providing you with the data that might be needed to do that kind of research. Okay? Well, I'll keep going. And, I want to give you sort of, well, let me go to this one first so to give you some idea. So in the United States, we have about 40,000 cameras in the United States. In Texas, we have about 2,200. Now, in some of the southern states, we don't have quite as many, and we're hoping that this webinar will aid in helping us seek new partnerships for cameras in some of the southern states. We'd love to work with any of the DOTs or any of the other universities that have this kind of data, or maybe they have RWIS data, or they have other mesonet data that's camera or imagery specific, or even if it's not imagery specific, it might be other types of data that can come into this network to help. We're always seeking partnerships, whether they be private, public, or just working together to look at new research questions. So if you have cameras or if you have assets that you think might be good as part of this platform, we can work. Harris would love to work together with you. I'll just point out down at the bottom, we do in our weather detection analytics, they're about 96% detection accuracy, about 2% false alarm. And we validate that manually every month by every time we do an observation, we also provide an image, and we're able to statistically go back and look across time and do a random draw and get our statistical accuracies and false alarms from that. So that's how that number is kind of come to, all right? So I'm going to sort of just come back into the application a little bit. So this is a visualization of our API. So for those of you who don't want our data or could use our data or would like to ingest in our data, there is an API for developers that you can come into, and it's a simple JSON REST API that you can basically come in and ask for our data. And we provide you all the information that you need in order to come in and actually query our system, and it will provide you with all the data that you see that I'm visualizing in our map visualization. It has all the same capabilities. I want to point that out because you don't have to just look at the map. You can actually use our data in your research by just querying the system programmatically. All right. So let me get back to the map. Okay, so I just let me give you some idea of some of the queries that you can do with this with the system. And I'm going to look at road weather. I'm going to just toggle for road wetness. If I wanted to just look at this area, say this area that's in my viewport, and I wanted to see sort of all the poor visibility, I can simply touch poor visibility in that area and do a simple search. And it will basically bring out on visibility all of the images or cameras that over a course of time, and this is all time stamped, each camera that has it is found and detected this poor visibility or this phenomenology. And I can simply touch a particular camera, which is, this looks like it was in Louisiana, very poor visibility. And I can look at that camera over time and see when that happened. And if you can see, this is one of the big advantages of Helios, right? So not only do you get a more dense ground network than you would with an RWIS system, but now you can see how fast, right? So these are 10-minute segments. This is closest to us. And then it goes back in time, right? So during this time, right, it's clear, 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 clear. And then all of a sudden, within 20 minutes, a big rainstorm happened to it, because you can see the red icons show when our algorithms have started to detect, and the gray is when they detect good. So within 10 to 20 minutes, a rainstorm came through that area and then cleared up. And Helios caught that localized piece. Now, did the RWIS or any other system see that? We don't really know. But we know on the roadside that we caught that actually was occurring, right, or about to occur, as we saw the deterioration of the conditions and then the clearing of the conditions as you got closer to time. So Helios gives you that ability to sort of like see the timeline. So you can go and do transitions, you can do durations, you can go back and actually analyze, well, how did this actually happen? And if you wanted to, you can actually go back and ask the system, you know, show me all the cameras so we're had the greatest amount of rainfall or alerts across a month or 2 months or even 6 months. So that's a sort of an indication. And I can do the same thing with road weather. I can say, show me all of the, not poor visibility, but just show me all the wet. Show me everything that's really, really wet. And the system will go in and query for you and it'll show you all of the cameras that caught wet roads for you. And you can do the same thing, like I said, you can go back, look at the same day camera, look at it through time, right? And you can see just recently in Baytown, Texas, they had a, excuse me, a localized storm come through. This is within the last 10 to 20 minutes. Prior to that, everything was nice and calm. Okay, so that gives you some idea of how the system sort of operates, and you can go through time if you really wanted to. You can look at, and maybe I'll do a go back a little bit in time, maybe in Oklahoma. Let's go back in time and let's come up into Oklahoma. And if we want to look at Oklahoma, everything looks nice and clean and clear and pristine, right? There's no rain. If you notice, we don't have a lot of cameras in Oklahoma. We'd like to get a lot more cameras in Oklahoma. But if I wanted to go back and look at Oklahoma City, I can go back and say, well, you know, but show me maybe in a month's time what actually was going on there. I can easily query the system for observations and say, well, show me maybe wet. And let's go back in time a little bit. Let's go back into August sometime. And give me all of those. And it'll go back in time, and it'll tell me all of the cameras back in time of when there was actually wetness. Now, although there wasn't in Oklahoma anything now, but in the past they obviously had some really bad stuff going on. Right? So it enables you to go back also in time and actually look at exactly what has happened, how the events actually occurred, even historically. Okay. All right. So I will come back out a little bit. And like I said, I'm using the visualization system that is available from Harris if you like this actual visualization system. Very easy to use. It's basically just like any other tool set. So I'll give you just a little overview of it. So Helios can display icons in different ways. I'm going to do that. I'll tilt the map just a little bit. So we can display them in icons. So you see the red icons meaning good, bad, depending on, you know, whatever phenomenology you're looking for, road weather, whether it's snow, partial snow. I'll get into that in all the analytics we have. But if you don't like the icons and you're just looking for areas, you can also pull up Helios's weather alerts. And those are really geared to show you and point out to you where on the ground, even though you see Doppler saying that this place is covered, where on the ground do we really see something really, really bad, right? And I think this is a visibility, and I'll look at these two kind of, because you don't really see a lot going on there, right, as far as Doppler is concerned. But if I touched on visibility on the icons and visibility, you see there are icons in that area, and this is the Blue Ridge going through here. So if I touch on that alert, you see that this sort of alert is a Helios alert, and if I look at those cameras in that area, you'll see there's extremely bad visibility going on there, and it's been going on for quite a while. So not only can Helios give you the point observations or the camera observations, but it also can give you sort of like a geofence to where you can warn individuals of areas where there are sort of localized things going on. And this is a prime example. If I zoom in here, this is a prime example of localized fog. All right, so you can see there's areas of clear within the system, right? So where everything looks great, right? It doesn't look that bad. But in a couple miles, as you move going to the west, you're going to run into severe visibility. So those kind of look-aheads and this kind of capability to actually detect this localized fog is really where Helios really shines, because it's able to detect that kind of, as long as there's a camera there, right, it's able to detect that kind of capability, right? And I don't think, let me check if we have something else going on there. No, so the National Weather Service, we have the ability to push up the National Weather Service warnings, and there were no National Weather Service warnings for fog in this area. So Helios detected something that even the National Weather Service did not. And those are the real values that we see, particularly in transportation, as the network expands, right, and we move not only to interstate but secondary roads, and we get more and more denser. We're even looking at adding vehicle camera data into the system to even densify the network even more. But we see that kind of capability, and I see that happening here as well down in this area too. We get an extreme amount of fog, and this must be some kind of a valley, but yeah, it just looks like it's just tremendous fog there. You can see the history, it's just been fog all for quite some time. Yeah, it's just bad fog. And you can see there are trucks and everything trying to go through that, but very poor. So, you know, if this kind of information can get out to the public or to transportation companies and logistics companies, very important information to know about as they're planning routes, as they're trying to understand how weather is impacting the roads and how it's impacting just the area in general. Okay. All right, so I'm going to flip back a little bit to the PowerPoint presentation. So, like I said, we love to work with anybody who can help us boost up these numbers as far as our camera network, or any Mesonet providers who might have cameras. We are also very interested in working together with you. So let's talk a little bit about machine learning. I know it's a big buzzword in the industry, but we really feel over the last three and a half years that Helios has been in development that machine learning is reframing the ability for us to extract these types of environmental conditions from traffic cameras. And if we looked at the previous way that we would apply computer vision to some of these kind of problems, it would be very difficult, right? You have pixel-to-pixel registration, you have cameras moving, you have stabilization issues. You may need more than one frame to actually look at some of these phenomenologies. Machine learning has provided us a single frame detection for every analytic that we have within Helios. So we use a convolutional neural network for deep learning, and we train against millions of images simply because the network provides us with a whole host of variability, and we do pre-screening of images as well. So we're always looking at cameras, looking at the sky or something crazy that's not normal, and we screen those out. So we can literally repurpose any camera, pretty much, into a weather sensor without any type of refit, and that allows you to densify the ability to provide mesoscale ground truth observation. All right, so what do we actually detect? So we have a suite of machine learning algorithm modules. So in essence, anyone doing research with us or wanting to work with us could actually encapsulate an algorithm, whether that be in MATLAB or that be in Python, or if you're using TensorFlow, or if you're using any of the Google tools like Keras on machine learning, all of those are the same type of tools that we're using. And they're sort of componentized, so we can pop an algorithm in and out, you know, depending on what it's actually looking for. Today, Helios ground observations enable you to see dry, moist, and wet pavement. So we can actually show you over time how the road is going from wet and drying out, or how the road goes from wet or from dry and starts to you know, get to moist and then wet. You can add on top of that the second row on the left, full and partial snow, is also part of our analytics. So you can actually look at the transition going from dry to wet to partial snow cover to full snow cover, and then back again from snow to partial or slush to wet, moist, and then dry. All of that is captured in the fidelity of the algorithms. We've added recently pooling and ponding. So we noticed in a lot of our imagery that we were starting to see the second row down to the right, that we were seeing lots of accidents after these kinds of pooling, where we see large splash from cars, whether it's high speed or we see even splash at lower speeds, 20, 30 miles an hour. Now, hydroplaning is much more prevalent during high speed, so on the interstates, but we noticed that we did correlate, even from our network, that when we saw this kind of ponding and pooling, that we saw accidents occurring. So there's some correlation there around, of course, standing water and you know, high rates of speed for vehicles and hydroplaning. So we've added that analytic. Visibility is another part of our analytic suite. So we can go from good to hazy to reduced to poor, and those have distance equivalents, or so they're not necessarily, or they're quantifiable. So we've correlated those with actual visibility distances, so you can actually see the graduation or the fidelity also in visibility. And then we have one for heavy rain. Heavy rain is really correlated to the National Weather Service's heavy to moderate to moderately heavy rain. So that's about 7.6 millimeters per hour in rain intensity. That's when that alert would trigger. All of these are active capabilities. So when we see the capability, we can push you an alert, or you can pull every so often if you want. But it can be a very active system instead of more of a passive system. And these analytics all work every 5 to 10 minutes. If you have a camera that gives us an image every 1 minute, we can actually produce the analytic in 1 minute if we get the source imagery at that speed. So, you know, how many analytics we make over the course of a time period is really up to the source provider's need on, you know, its temporal need as far as, you know, what's important to them. It's designed for highly variable imagery. So from these camera images, we get images that look completely different. One state's DOT camera system is completely different from another state. Finland is different from Alaska, and we've been able to provide pretty much single models that work across our entire network. One that's different, we have a visibility that's different, that's a different model, and that's for aviation. So we've worked with the FAA, and they've given us a different metric for flight, for aviation. And we have a visibility analytic specifically for the FAA that's done in Alaska. Okay? And as I said, manually validated at about 96% detection rate. All right. So upper right is in Colorado, 2 big accidents that occurred. Lower I'm sorry, upper left is the accident, and I say if they could only know the changing highway conditions. Well, Helios actually did. So we took, excuse me, allergies. We took a timeline of that same area, and Helios actually, if you follow it across to the bottom, it shows you how it went from kind of a wet road to more of a moist road to partially covered, visibility started to decrease, and then to a snow cover road to fully covered road, and then the next image from the lower right is the one in the upper left, is when the accident occurred. So it's those kinds. This is Interstate 70, which is notorious for this kind of weather. If anybody has ever driven that one, it's a scary place at times in the wintertime. And this sort of allows you to get a much better look on the roads, right, than maybe the RWIS stations can give you normally in normal DOT. So that's sort of one example of understanding real-time road conditions to where you can be more proactive. I showed you a little bit about the real-time localized fog that we did in real time just now. This was one we caught from the National Weather Service that one of their forecast offices actually had to change their fog advisory because Helios had caught an area of fog that the National Weather Service missed. So we detected fog in that area. If you look at the camera in the lower right, it actually was fog, and they extended their National Weather Service advisory out into that area. This is one that we see all the time. This is opposite. I don't know if the group knows about the weather phenomenology called virga. So virga is basically when you have lots of rain in clouds, and it's really raining, but you have this warm, warm level of air underneath those clouds that evaporates the rain, and although it looks like it's raining, the rain never hits the ground. This is sort of opposite of virga, and we've seen virga. Helios is good at catching virga as well. This is opposite of virga. There's no Doppler indicating that there's wet roads. And sure enough, when we look, and you can see the red and the red box, Helios did detect that there was a localized storm that came through that. We showed this to some people in the northern states, and they were really, they really liked this because this would be, particularly if the road temperatures were low, this would be an indication or a place where they would think that there would be road ice. But this is an indication of how Helios sort of is detecting things that previously, right, a lot of other traditional weather enterprise data is not showing you, much similar to what I saw in that derecho in 2012. And, you know, this is sort of how we think Helios really shines, right? So you get more precise information when you have this scattered shower, right, is predicted in the forecast, and you can provide better localized wet road information when not forecasted for. Right? Okay. I want to get into this as well. It's not just point data. Since we store all of our data, including the imagery, you can actually go back in time and start querying for analysis from our API or even from the UI. As I showed you before, you can, and actually I'll show you the trending side on the UI. So you can show me the worsening visibility of the last 30 minutes in trending, right, in duration. You can look, you know, over 3 months. Or just, you may just want to show the transition state. Show me when the road goes from dry to wet or from wet to snow. That might be important to you in a more active way to where you can give alerts. Helios has that ability to and precision and accuracy to tell you when a road's going from, you know, wet to snow or dry to wet. Or you can combine our analytics that's in the lower right. So the upper lower right, light rain and mist, that's if you combine our wet road analytic with our hazy visibility. And that tells you there's sort of wet particulates in the air. If you combine our hazy analytic with our dry road weather, that the road is dry, then you're getting more like a you know, air particulate, smog, right, that kind of capability. So you can use the analytics together and combine them, concatenate them, and they can give you these types of different types of analytics. And that can all be done via the UI or the programming, the API interface. Those queries all can be made. Okay. Just a little bit, I'll show you a little bit on the trending. Let's see if we can find a some kind of alert from the National Weather Service. Okay, there we go. So, all right, the blue is a National Weather Service weather alert down in Louisiana. It is a special statement from the very moist, unstable tropical air mass. So when we look in that area, if we want to really see what's going on the Helios side, we can give you trending information from that area. So we look across that morning weather, and we can go back in time, and we can actually see that there's been some poor visibility in certain areas within that area. And I think I can go to that, and then go poor visibility, and search, and it should give, yes, it gives me exactly when that occurred. So you can see in these, in Alexandria, Louisiana, and then if I look across, I can get, so it's been pretty good, pretty good, pretty good. Let me see if I can find, okay, so there, and then, of course, we can go into the night. So we had some fog forming, and then our visibility analytic also works at night. You can see at night it was still sort of foggy, and then it started to clear up at night. And the analytics also were performing at night. So not only in visibility you get day, but you get 24-hour capability from the system. So that's an example sort of some of the trending capabilities that you can do, or even durations that you can do. Using the area, you know, tapping a National Weather Service or querying a National Weather Service area, or one of Helios's alerts, you can do that with as well in the visualization system. Just so you guys, I'll take you through. The black means that there's no reporting coming from that particular station. And if there's anyone from the Texas area, we'd love to get more cameras from Texas. Sometimes the cameras go down. We sort of don't have a sort of a limitation of the system. Fortunately, they don't go down too much. These are all temporary. So we don't report an observation if the camera is not sufficiently giving us the right type of information. We sort of shut that camera down until it comes back up. You can see they come and go. Helios is pretty much a very dynamic system. So these black icons sometimes go black, and then they come back as soon as the camera, we determine the camera has come back, they come back online for detection of analytics. All right, and that's sort of how the system kind of breathes. It's sort of a very dynamic. So in the UI, it's very simple to use. Viewport search just searches for cameras or things within your viewport. So if I wanted to see all the cameras here that I'm looking at, I can touch cameras, and it gives you all the cameras that are in that area. So you can go to a particular area and look. The Helios alerts are, of course, are the alerts that are areas and not the icons. And the Helios observations are you know, visibility, road weather, whether it's snowing, and precipitation. And then we provide you with context by allowing you to get the National Weather Service alerts, radar and infrared, which are coming from the National Weather Service. And we have other controls like a geocoder if you wanted to enter in a zip code or something like that, if you wanted to see the scale that's on the map. So those are sort of very simple, easy ways of visualizing what Helios is actually doing across the map. And then some of the advanced queries that I did are very simple. They're here. If you just want to see, you know, cameras, let's say in Pittsburgh, you can just search for cameras in Pittsburgh, and you're only going to get the ones in Pittsburgh. I can add on to that. I think I can do bridges, BRD. think that might work. Yes, okay, so I can only get bridges, right? It'll give me the ones that are on bridges. So there's metadata searches that you can do on the system that will help you. I think I can do I-279. I'm trying to think of a big one that's in Pittsburgh, I-279, I guess. I don't know if I'll get that one right. No, let's try 279. Yeah, there we go. Okay, so now it gives me I-279. So you have all those queries that you can do within the UI as well as the API. And very simple to use. Nothing really special. You don't have to have any special kind of knowledge on doing that. So I want to finish up. Our time is running, getting kind of late. So I want to finish up with just some benefits. So, right, the benefits really is really about real-time localized information. Helios really shines at that, and the denser, the more cameras we get into the network, which we're adding cameras almost every week, the better that is. So you get better road coverage to increase awareness, right? You are able to capture extremely localized conditions like fog and road conditions. It optimizes already existing assets, and we keep historical archives that are not available from the source provider. So it gives you a way to go back and actually start to do predictive type capabilities from the data, right? So you go from passive to active, right, to active. Instead of waiting 20 minutes or 30 minutes, you're now getting alerted to things. You can provide better public warnings. So more effective risk messaging. Not only do we provide the observation, but you get the image. So you might want to supply the image of, you know, terrible fog in this area. This is what it looks like. So it improves messaging. And of course, verification, right? Forecasts always suffer from poor verification, particularly precipitation is the killer. So you have just a denser network to look at that. And you just have a more complete and comprehensive verification system of all things. I wanted to talk to you guys about traffic side or activity side things that we're working, because this might spur some of your thinking. We are looking at, in addition to weather, doing more scene activity so that we can combine the two. So we're looking at incidents and congestion and single lane. And we're also doing some things in tracking specific types of vehicles throughout the network. And those are some things that I wanted to put into your head to see if maybe there are some other things that are of interest that we can collaborate on with this big surveillance system that we have to solve some problems that you might see for the public. Like I said, I have a simple REST API. We can work together with you guys, give you guys an evaluation copy. We do have a program for universities, and we are excited about working with anyone who wants to work with us and take advantage of this system. We think it's quite unique. At least I think it's quite unique, but so we can provide you access and keys to get into the system to try it out and test it out or work with us. So here's my information. You can always call me. You can always email me. If you're looking at, if you're a university and want to do some work, we have a program for that as well. Andrew's not here on this call, but I gave his email address. And you can find more information at helios.earth and helios.earth developers. Okay, and I think that was all I had.
All right, great. Thank you so much, Eric. Wow, yeah, does anyone have any questions? Okay, well, I guess I have one question if you don't mind. So now, how long has this program been going on? Like when did the technology start? How long has Harris been working on it?
So the technology started about 2013.
Okay.
And so late 2012 was the derecho. We started to look at this kind of technology in about 2013, about the 2013, 2014 kind of time frame. We started using traditional computer vision to try and work on some of these very difficult problems. And then as machine learning, Harris has stood up internally a whole COE around machine learning. We started to take advantage of the machine learning and deep learning capabilities that Harris started to put into place. And then we migrated the majority of our algorithm detection from traditional computer vision to machine learning. So we've been doing the machine learning for about the last 2.5 to 3 years, and we've actually become students, really, of machine learning and weather phenomenology. So it's been a journey getting to where we have gotten, but we have really Harris has almost perfected, sort of how to do this in a long way, and I think that capability and that knowledge can be leveraged by some of your members to do other things and new things.
Definitely. I mean, it sounds like such an exciting project. Have you had a lot of good reception from the state DOTs? Like, have they been your main partners, or have you found more reception among universities, or is it kind of equal, or like who have you seen that's been really excited about it so far?
So, when I first sort of conceptually looked at this, it was really kind of fundamentally geared at the weather forecast offices at NOAA, or just those who are doing or if you look into the broadcast side of things, right? Those who are really trying to provide this kind of localized information to the public. And we found great traction with NOAA and the FAA initially. So NOAA, particularly at the regional forecast offices, all the regional forecast offices now use Helios for prior to putting out nowcasting. So they have sort of been our biggest. NOAA, right, has been if you take from NOAA, the National Weather Service, has been sort of the biggest proponent of seeing this kind of technology and adopting it. And now Helios is part of the National Weather Service Mesonet program. It's being used even within that entire NOAA agency. From the National Stormless, so NSSL is doing work with it to help them on the Doppler radar side. We're seeing all kinds of the Prediction Center here up in Maryland is using it to help them with with various kinds of analysis. And then the FAA has also been a big proponent on the visibility side, particularly with aviation visibility. And those two big agencies have been our foothold. And now we're down at the state level, so we're talking to you guys. We really haven't exposed this too much. I think our biggest advocate on the state side is we have a public-private partnership with Florida DOT. They have all of our analytics. They provided us with a large set of cameras that even the public doesn't have, so that they can actually use the technology at their TMC level, the regional TMC levels, to protect against fog. What we didn't realize initially was fog in Florida kills more people than hurricanes a year. So they were having all kinds of problems with localized fog. They are one of our largest proponents of the technology at the state DOT level.
Wow. Well, sounds like some great partnerships. Oh, yeah. Sorry. Go ahead.
Sorry about that, Michael. My name is Dominique Pittenger. I had a question about what kind of legal impact are you seeing now, or do you anticipate in the future? Because I see now that if DOTs are getting more information about current road conditions while it's happening, I'm thinking that impacts the legal standpoint, especially as you're talking about, traffic accidents and road management. And so what does that look like for you right now?
So, on the legal side of things, we act as a supplemental system to the National Weather Service. So we never we never put ourselves out there as we are the, you know, purveyors of you're supposed to take specific action because of looking at Helios. It's really a supplemental system that should go along with, right, the National Weather Service is basically the source for if you're getting information that you're going to take some kind of action. They are the source for this kind of information. So we definitely look at this more as a supplemental system, and we state that, you know, quite plainly. On the surveillance side, we really don't, the cameras aren't really geared to looking at faces or license plates or anything like that. So we basically stick we focus our analytics on public safety, which would be, we're looking at, excuse me, my allergies are coming back. We look at weather, we might look at congestion, we might look at things that are general in nature, right? So we may look at, we're not looking at any specific individual, right, or trying to, you know, locate any specific individual. We may follow a car, right, down the road, but we're not trying to get into any kind of surveillance kind of capability. But we're trying to keep it more on the public safety, you know, a supplemental system that someone can look at. And for us, right, if you look at the Helios product, when we make an observation and we give you an icon, there's a camera image that goes along with it. So you're getting not only the observation, but you're getting the camera image validation of this is the actual condition. So we try to limit our liability in that way, if that answers your question.
Yeah, and I was just wondering from the DOT side of it too. I mean, I wonder if that changes their liability, but I think you really addressed my question, and it's really supplemental. It's not necessarily the tool, so that's helpful. Thank you.
Yeah, and I think on the DOT side, they're using it supplemental, so they're integrating some of the data into some of their tool sets that give them a little bit more information around what's actually occurring, right? And then they can use their primary systems to, you know, make adjustments. We have not seen yet, but we think this is coming as machine learning gets better and better, that some of this will eventually make it into the initialization of forecast modeling. Now that hasn't happened now because this is kind of a new technology, and you know, a lot of people like to take a look at it and, you know, evaluate it and see how, you know, how well it works. That's a little down the road, but I do see in the future, as we continue to improve the accuracy, the precision of machine learning in these fields, that these observations end up becoming, right, initialization observations to improve forecast modeling. But I think that's a little bit more down the road, and right, there's some liability issues with that, right? So the forecasters want to make sure that these observations are correct before they actually add it into the model.
Great. It looks like we're almost out of time. Does anyone have any last-minute questions? If not, I want to go ahead and thank Eric Dixon for his great presentation. Like I said, we're going to go ahead and put it up on our YouTube channel and send it out to anybody that wants it, and then you can disseminate it and share it and watch it again. So we should have that coming later this afternoon. And our next webinar is going to be held in November, so please stay tuned for more details about that as we put that together. So thanks again, Eric, and thanks again, everyone, for tuning in, and appreciate the presentation. It was excellent, and we'll see everybody again in November. So appreciate it.
Yeah, thank you. Thank you for the opportunity. Thanks, everyone.
You bet. Bye.
Bye-bye.